So here comes the fun part. Now we're going to clear the guinea pig hard drive of all of its data and pretty much replace it with zeros for every usable sector of the hard drive. At the end, we're just going to fill it to 510 bytes with the zeros, and then the last 2 bytes, the boot sector code. First of all, if you start from nothing, you start by creating your assembly language file, which is right here. And then after your assembly language file, you convert that to a bin file, and then transfer that to the boot sector of the USB drive or your floppy drive. I don't have a floppy diskette or a floppy drive, so I'm going to use my USB drive, a spare USB drive, and copy it to the boot sector of that, and then boot the guinea pig computer using the USB drive, and hopefully it will recognize the USB as a valid bootloader, and then erase the hard drive in about, I don't know, a few seconds. There's not much on that hard drive. So let's go ahead and convert this file and then transfer it to the USB drive. Now we have the file over and ready to be converted. So as you can see here, we're using ASM, the Netwide Assembly Language Converter, something like that. And the output file is osiso.bin, which I'm going to change the name. I was going to do it on CD earlier. That's why you have ISO at the end. And the input file, which is hddclear.asm. Now we're going to convert that to a bin file. Good, no problems. And we have OSISO. Let's check the size on that. 512 bytes exactly. Cool. Now we want to make sure we cannot execute this, because if I execute it right now, it's going to kill my computer. No, okay, cool. No. Okay, so good. So we have the bin file, and now all we need to do is transfer it to my flash drive, my other guinea pig flash drive, and then boot up the test computer. Now it's actually time to transfer the bin file to the flash drive and make the flash drive bootable. But bootable is kind of a overused word. Pretty much anything is bootable if you modify its first sector, and in order to do that, we simply need to write to the actual drive instead of SDB1 or SDC1. When you take off the 1, it actually starts at point 0, and therefore you overwrite the first sector or the first space for that drive. So the flash drive is located at DEV SDC or SDC1. You want to make sure you confirm that first before you start copying, because my computer, it should be SDB, but actually my hard drive is taking up that space. You can confirm that by going to dev, disk, and by label, and then here goes my flash drive's name, and then you look at the properties, and you can see it's SDC and not SDB. You can confirm that again by going to ID, and then mine is Kingston Data Traveler, and you can see it's SDC. So I'm sure of the location of my hard drive. You should also be able to remove it, so let me see if I can remove it right quick and see if that changes. Yep, it was 2 USB data travelers, and now there's only 1, and yeah, it's gone. So it's definitely SDC. Let's just confirm one more time, because this is very important. You can only do this. This only happens once. You only have one chance of this, so it's better to confirm as much as you can. As you can see, there's only 1 USB Kingston. Take it out. Wait a little while, and then put it back in. I don't know where to go. Yeah, it disappeared because I took it out. Okay, let's put it back in. And there it is. And just confirm one more time. It is still SDC. Okay. And it's 0 bytes because, I don't know. I think I cleared it off. Yeah, it's empty. Alright, so let's go ahead and write it then. Now, in order to write to the flash drive, I'm using Linux's dd command or double D command. And simply, I start the format as dd. F equals location of your bin file. Of equals the location of your device. Let's go ahead and write that. Permission denied. You also want to make sure you have you are a super user or you have elevated privileges before you initiate the command. And as you can see, 512 bytes copied. Oh, what is that? A millisecond? It's quick. Kilobytes a second. That's why it was so quick. Oh, doesn't make sense. Whatever. So there it is. Now we're going to boot this and destroy data-wise the hard drive on the guinea pig computer. So let's go ahead and see how that works out. And if you should know, AH and AL are the upper and lower bits of the AX register. So if you set AL or AH to 0, I mean AX to 0, it'll also zero out the AH and AL. And therefore, if you use INT13, you won't use your correct function because AH will be set to 0, and that will simply reset the disk instead of writing to the disk. Alright, so I got the flash drive here. Let's go ahead and pop that in. And go ahead and plug this power cable in. And it's booting. Let's see what happens.